Now, we'll consider median, the estimated values of median, then we have the mode, the estimated values of mode. But we'll start with median first of all. Median is all about middle values. If you want to consider median, for example, you understand that if I have values like 2, 3, 4, I will tell you that the middle value is 3. Now, the middle value is 3. That's what you call median. But in variance, the median for data that are ungrouped data, scattered data. Ungrouped data, basically, when you have media for them, you calculate their median based on n plus 1 divided by 2. Now, you can also calculate their median as n over 2 plus n over 2 plus 1. Now, this is based on the fact that this is only possible when n is odd, and this is possible when n is even. An even number is a number that can be divided by 2. One odd number is a number that cannot be divided by 2. So from here, let's take an example. It said find the median of 25176. And the question 2, let's start with question 1 first of all. These are for ungrouped data that are scattered. So from here you have question 1, you have 2, you have 5, you have 1, you have 7, you have 6. Now, that's one of the importance of median. Median is easily calculated. In fact, it can be calculated from values that are discrete, scattered values. It's easy to calculate. That's one of the importance of. But the disadvantages of median is that median, you need to rearrange median. So if there are many, you have to rearrange them. You have to take the time to rearrange them. That's the disadvantage of median. Now you have 25176. 25176, let's rearrange them. Rearranging them will be 1, 2, 5, 6, and 7. Now, how do we get the median? We'll discover that we have 1, 2, 3, 4, 5. So, but the number of n is equals to 5. And this n is odd. So because it's odd, we're going to use the first value. That is, what it means is median is equals to n plus 1 over 2. So that will give us 5 plus 1 over 2. That will give us 6 over 2, which is equals to total. So in this whole value now, here down to here, which of them is in the total? That's 1, 2, and this is 3. So therefore, the median is equals to 5. I believe you understand this. So first of all, you calculate the term of the value, and the term of the value is obtained from here. Why are we using n plus 1 over 2? Because 5 is an odd number. So that is for that. That's for the first question. Let's consider the second question. The second question is also very easy. Now, so the second question, you have question 2, you have minus 5, you have 6, you have 0, you have 7, you have minus 3, then you have 4. So if you rearrange them from ascending order of magnitude, for the ascending order of magnitude of arrangement, it's easy. What you just need to do is to take the smallest. From this value, the smallest is 5. You have 5, you have minus 3, you have 0, you have 4, you have 6, and you have 7. Like the banker will say, minus 5 is bigger than 0. Why the mathematician will tell you that 0 is bigger than minus 5. Good. Now, because the banker believes that you need to borrow money to do business, and the mathematician believes 0 is greater. The other way around, I think I will buy the ideology of the banker, because if you have that money, you can use the money to make more money. But if you have zero, zero cannot generate any money. Now from here, you have something of this nature. So you have minus 5, minus 3, 0, 4, 6, 7. Good. From this analysis, it's easy to say 1, 2, 3, 4, 5, 6. Oh, n is even. It's equals to 6. That's its even. So because it's even, we are going to make use of the second formula, which is this. And that will give us median is equals to n over 2 plus, what do we have again? N over 2 plus 1. So that gives me 6 over 2 plus 6 over 2 plus 1. That gives us 3 plus, so the third term is a term of its own. That's a term of its own. So plus, yes, this is a term of its own, that's a term of its own. So 6 plus that's 3 plus 1, that will be fourth term. So from here, where can you find the fourth term? This is the first term, second term, third term. So the third term is 0, while the fourth term is 4, all divided by, so you have the third term, so 0 plus 4, that will be 4. So the median for this second here is 4. So from here, it's simple. So the first one, you have the n term, third term, and that's fourth term. You add the two of them, and you get the value of 4. Now, this is simple and very interesting. So as I said earlier on, the advantage of this is that it is easily calculated as a median. And the other advantage is that it can be calculated from even data that are not perfect or complete. You can always calculate median. But one of the disadvantages that is for rearrangement. That rearrangement takes a lot of time, especially when you have data that are so many. Trying to rearrange them takes a lot of time. So that's one of the major disadvantages of the median. So from now, we're going to consider median as far as group data is concerned. What we just consider are scattered data, which are on group data. So let's talk about that for group data. So now we're back again. You have the media that we've talked about. We're still on the estimation of media. Now, from here, you observe that we've talked about that of data that are ungrouped, scattered data. But now this is for group data. If you look at it, the media for a group data is calculated using the formula Li N2 CFF times the cumulative frequency. Now, from here, you have the value. So find the media of the distribution. For the media of the distribution, it's easy. It lengthens from here and ends here. So if you look at the data, they are group data. 60, 62, 63. And you see that the difference in between them is 2, 2, 2. So from there, the occurrence for the first was 5. Occurrence second is 18. Occurrence third is 42. And you have the occurrence for 69, 71 is 27. And 72, 74 is 8. Now, what do? You don't need to stress yourself. Just draw a very simple table. That simple table is one for the frequency and the other for the cumulative frequency. You already know how to calculate cumulative frequency by what? 5, 18, 23, 40, 60, just like that. And from there, cumulative frequency is equals to 100. Now, from there, it's easy. You cannot take it from there and say, okay, good. Frequency has its own, and that is cumulative frequency. So that gives me a cumulative frequency EF to be equals to 100. So now, the media class for this operation falls in between 66 to 68. So media is equals to 65.5. That 65.5 is the lower class boundary of this 66, which is 65.5. That's minus 0.5. Now plus 100 divided minus 23, which is just that class between before. So you have minus 23 divided by 42. Now, 42 is just after that class that you've talked about. The next one, that is why it is called FM, is the next class. So just after, so that's 42 times 3. So now from there, how do you get that value done? So from times 3, so you have, what's the difference? If you have 60, 62, so you have 60 61, 62. So from 60, 61, 62, that's 3. So you have times, so 65.5 plus 27/4 times 3. So the total value for my estimated media is 67.4 kilogram. So you can calculate the value of media via the formula media calculation. Now that is that. But there's something else we can do as far as media is concerned. What are those things we can do as far as media is concerned? Media can also be calculated from something we call an OGIV. It's called the cumulative frequency curve. The OGIV is the cumulative frequency curve. Media can also be calculated. And media can also be calculated from your histogram graphs. So for example, you have your histogram graph, or maybe something like this, something like this. You just observe that you can calculate your system from here and your frequency, your max. So you just observe that. For you to get that, you just look for a line here at the center, you mark it down. So where it divides it into 2 is what they call the median. So you must take note of this. It can be calculated, and also from the OGIV. It can be calculated from the OGIV. How? You have the OGIV, maybe your OGIV is like this. So the point where they intersect, where it divides the curve into exact 2 parts, you just locate, get that point, and take it down. So this point here where it hits is called the median. So median can be calculated from an OGIV, and it can also be calculated from a histogram. So you locate the point where the graph is divided into 2 equal parts, which is a symmetry, and also, or sometimes you use the word literally symmetrical values of it. Then you locate your first value, and from here you locate the value that divides it into 2 equal parts, and where that part is, you locate it down, hits the max. That is what they call the median mark. And don't forget, the max is always at the axis and the frequency is at the vertical. So from there we draw a conclusion now on media, and that shows that we have to move on to what we call the mode. Now we're back again. Let's talk about mode this time. We've talked about media, we've talked about the estimation of media. Let's talk about mode. Now, mode and its estimation. When you hear the word mode is all about that value with the highest frequency. That's all mode is all about. So if, for example, you have something like 2, 4, 3, 1, 3, 6, 2, 8, 10, 3. From this value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you observe that the value that has the highest occurrence is 3. You have 3 here, you have 3 here, and you have 3. So the question is, mode is equals to 3. Is that thing, is that value that has the highest frequency, that occur more, occur most. Good. Now, if for example, I have something of this nature, maybe I have max, and I have frequency. If for example, we have 20%, okay, maybe in percentage, 27 times 45%, it came 3 times, 70% appeared 10 times, and 82% appear once, and 94% appear 3 times. So if you look at it from here, what's the modal mark? The modal mark here is equals to 70%. The reason is because the person, the marks in this class, there are a lot of students. Some of them are 20%, 45%, 70%, 82%, 94%. But the student that had 94%, which are the highest in the class, those intelligent ones in the class, had just, they were 3 in number. And the 82 was just one person. That's the person who refused to give up. That's 70%, they were 10, showing that the class has a lot of very good students. Good. So 45 was 3. These ones are struggling to hit the 70. And you have 27 of them. Probably we'll call them the loaders in the class. Okay, now that's that. So we have marks 70%. Good. Now it's done or that we can have values of this form that we can say, look at this value occur more than any other value, and because of that we'll say that this value is the modal mark or the mode of the distribution. But this whole mode that I've discussed now and its estimation, this mode has everything to do with ungroup data. The data I just talked about are ungrouped, they are scattered. But what about a case when we have mode to do things to do with data that are grouped? Now let's consider mode of data that are grouped. Now for group data, mode for group data. LI stands for the lower class boundary. So you have the D1, which stands for the modal frequency before the modal frequency before the modal class, and this is the modal frequency after the modal class. So the modal class, the frequencies before it and after it is D1 is before it, the frequency before it, and D2 is frequency after it. That's the D1, the D2. So times. So from here you can take the values Li that. Now we have a question. Our question is simple. It says calculate the mode of the distribution below. The distribution is a little bit long. So you have weight, you have frequency, weight in kilogram. So you have 20 minus 27, that's the range, and the frequency there is 9. The range 30-39 frequency is 10, 40-49 frequency is 13. You have 50-59 frequency is 19, 69 frequency is 11. You have 70-79 frequency is 8, and 80-89 frequency is 6, and 90-95 frequency is 4. Good. So from there we can take out our value. So we have D1 to be this, 19 minus that 6. And where is that? So from there we also have 19 minus 8, which we have 6. Then we have 11, 8, and 6. So from there we can take our calculations. So before it and after it, that's the bone of contention now. So which is D1 and D2. So we'll take our calculation on that. So from the calculations, we take that. So the mode now will give us Li plus D1 plus D2 times C. So sometimes if some of your work you do see D1 to be changing 1, D2 to be changing 2, but don't bother, it's still the same thing. So when you have something of this nature, from here I can take my calculation on direct values. My L1 is 40. Okay, the modal class is 50 to 59. So 50 to 59, the lower class boundary becomes 49.5 plus what I have here is D1. D1 is T6, and I have D2. D1 again 6 plus 8, and times the value of 10. Now it's calculatable from here. So you have 49.5 plus 68 automatically is 14. So I'll have 6 over 14 times the value of 10. So automatically you're having 2 here, 1, 2 here, 3, 2 here, 7, and that would be 53.78. That would be the border mark. So with this your calculation, you can have 53.78 as border mark. So remember, D1 9 this that 19 minus 11 is 7. So the modal class, which is 19, is the modal class. That's where it's highest. So that's why it's 50, 59. So you have C to be 10. Good. So from there, you have your value L1 plus this, that times 10. And from there, you have your value 49.5 plus 6 times 10. And you have so 53.78. That gives you your direct value. So now we've talked about that, and it makes it easy. So in a something of that nature, you can also do other values like mode being calculated on a graph page. It can be, maybe you have a graph that you plot, and maybe you have some things like something like this. You have some things like this, some of that nature. You look for the highest of all. Maybe that's the frequency and that is the max. So if you look for the highest, all you just need to do is to draw a line to perpendicularly touch the end. Draw another line to perpendicularly touch the end. So where it hits here depends on how you want to do it. You take the one that perpendicularly hits the end here. Take another one perpendicularly hits the end here. So where they intersect here is called the mode. So most times you have mode, you have media, and you have value. So for now, that's the end of this particular unit. I believe it's interesting and you understand, and we'll see in other classes. I'm still your maths instructor. Thank you.